Hello, this is Lab 2, Charge Tape Revisited. So the purpose of the lab was to treat the tape as a line charge rather than a point charge. And then we approximate the charge on the tapes, and then we'll compare the results with Lab 1 and CloseScript. So the concepts we use in this lab, the first one is the formula to calculate the electric field from a rod, where R is the distance from the center, L is the length, and Q is the charge throughout the line. And then we also use F equals Q net to measure the effect of the field on the tape. So some assumptions we made, we assume the U tapes have the same charge, both in direction and magnitude. We also treat the tapes as line charges instead of point charges this time. And then the charges are distributed uniformly among the tape, and then we also ignore air resistance. So estimating the charge, we set the force of gravity equal to the net electric field times the charge of the tape, which is just Q. And then isolating Q, we get Q equals the square root of this formula right here. And then plugging in the values you saw earlier from Lab 1, we get that Q equals 4.65 times 10 to the negative 8 coulombs. So this is for our CloseScript code. We see we put in our estimated charge of 4.65 times 10 to the negative 8. And then over here, we see the electric force is pretty close to the gravitational force, but just a little under. And then we see a bunch of point charges. And on each individual point charge, we see an arrow pointing in the upwards direction, showing the repulsion from the tape below. And then the white arrow is represents the total magnitude of electric force pointing up, and then the yellow arrow represents the total magnitude, or just the force of gravity. So this is the most important part of our CloseScript code. This is like a nested for loop that measures the pairwise forces between all charges on top and all charges on the bottom. So basically, for every pair of charges, one from the top and one from the bottom, we calculate the electric force between them to get a repulsive force, and then we sum all of those forces to get the total net electric force. So that's why you see a nested for loop there. And then quick discussion from our previous lab, so from this lab, our point charge, or our line charge was 4.65 times 10 to the negative 8 coulombs, and our last lab, we estimated where we treated the tape as a point charge, we got 2.76 times 10 to the negative 8 coulombs. So the line charge is much bigger, and it is about 1.69 times larger than the point charge estimates. And why this isn't that surprising, because a tape is much closer to a line than a point, and we can assume evenly distributed charges among the tape. So the line estimate will be much closer to the true value needed to float the tape.